Measures of central tendency in variation, section 11.5.1. We're breaking up section 11.5 into 2 days. There's a lot going on, especially the second day, so we're kind of breaking it up over 2 days. Today is kind of more the probability part of it. We're getting into a lot more like some of the statistics part of it, which is really cool. And that'll be more tomorrow. But measures of central tendency and variation, section 11.5.1. There we go. So expected value can be thought of as expected value can be thought of as the long-term average of an experiment after many trials. Okay. The table shows a probability distribution for the variable x. A probability distribution table pairs each outcome with its probability. For example, like if we were to roll a dice, okay, if we were to roll a 6-sided die, you know, we could just keeping track of the numbers that come up. Like 1 came out like 3 times out of 10. Okay, so you know the probability of getting a 1 was like 3 out of 10. That type of thing. That's what this is. It's showing the probability distribution of all this in a table. Okay. To find the expected value, which is what we're going to be doing today. When we find the expected value, what you do is you take the outcome times the probability and add each one of them together. So you're taking the outcome times the probability and adding them together. And this what gets you then an expected probability. All right. For example, this table shows the probability distribution for the number of red marbles selected when 3 marbles are randomly selected without replacement from a bag with 4 red and 6 blue marbles. Find the expected number of red marbles selected. So when you're selecting this, 0 came out like 17 times out of 100. 1 came out like 50 times out of 100. 2 came out 30 times out of 100. And 3 came out 3 times out of 100. Does that make sense? Like you think probably out of 100, right? Percent. So to find the expected values in like how many on average, long-term average, should you expect to pull out? If you always pulled out 3 red marbles, how many on average should you always expect to get? Well, to find that expected value, okay, you multiply the outcome and the probability, and then you add them together. And that's what this shows right down here. So 0 times 0.17, 1 times 0.5, 2 times 0.03, or 0.3, and then 3 times 0.03. You multiply each one of them together, and then add them. And what this says is you are expected to get about 1.19 on average. So on average, you're going to get, you know, at least 1, probably more than 1, about 1 or 2. Basically what that's saying. Okay, this is expected at value. This is used a lot of times in sports. We have a problem later on, but I was talking earlier, like free throws. Like how many free throws should you expect to shoot a game? How many free throws should you be expected to make a game? Okay, probability is there. A lot of times they're used in baseball, you know, number of hits, expected number of hits or number of runs. Have you ever seen the movie Moneyball? They're talking about like their expected runs like per game, those type of things. That's what this is. So it's using the probability along with the outcomes and all these different things. This gets into some really cool higher end statistics. We're just looking at the basics today. But some really cool high end statistics. Okay. Yes, sir.
So you multiply the outcome probability and you add what?
To the next outcome probability. So you take each one of these, multiply it together, and then you add the results.
Oh, okay.
Yep. So let's look at what the first one looks like here. Number 1. The probability distribution of temperatures in degrees Celsius from a chemistry experiment is shown below. Find the expected value of the temperature during the experiment. Okay, now again, if you have fractions, that's fine. You can use fractions or decimals, doesn't matter. So to use the formula for expected value n, so that's like saying, you know, x1 times p1, x2 times p2, etc., etc. So what we're going to do here is we're going to take our outcome and probability and multiply them together. So I get 4 times 2/13 plus, and then I go to the next one, 5 times 4/13 plus 6 times 3/13 plus 7 times 4/13 plus 8 times 2/13. So take a couple seconds here, multiply all those out, and that's where you get your expected value. So try that. All right, so when you multiply all those, do you have a fraction or a decimal answer, Maddie? What do you have for a fraction? Is it 86 over 13? I thought it was 90 over 13. I think it's 90 over 13. Then you end up with 90 over 13, which actually equals, isn't that 6 and 12/13? Anybody?
Well, let's divide 90 by 13.
Then you end up getting 6 and 12/13, which is approximately 6 point what? 6.92. There's your correct answer. So what that's saying is, on average, over a long-term average, you'd expect to have a temperature about 6.92 degrees or about between 6 and 7 degrees on long-term average. Okay, that's what you'd expect to see there. This is Celsius.
So for all the answers,
So let's look at the next one here. Number 4. The probability distribution for the number of free throws that Larry makes in a game is given below. Find the expected number of free throws that Larry makes in a game. Okay, so this is good. So probability distribution for the number of free throws Larry makes in a game is given below. Find the expected number of free throws that Larry makes in a game. So I'm going to take, what?
This is Larry Bird.
Larry Bird, exactly. I mean, 5, 6, 7, 8, of course. The guy's a legend. Legend Larry, man. So you're going to take 5 times 0.21 plus 6 times 0.58 plus 7 times 0.14 plus 8 times 0.07. So as you go through this here, multiply those, add them together, and find what the expected value is. Take a couple seconds to try that. All right, so as you look at this here, when you multiply them all up, you get an expected value that is approximately, what'd you say, Mark?
6.07.
6.07, nice job. So on long-term average, he's expected to make about 6 free throws per game. I'll take 6 extra points per game.
That's not right.
Is that if he gets fouled not a lot?
You can go a little bit more with that, and then depending on how many he shoots, yeah. Because then you look at his percentage. So I mean, you could look at that. Try number 5. Talking about junk mail here. Take a couple seconds to try number 5 now. All right. So as you look at this here, when you multiply the probabilities and expected values here, multiply them, you add them together. What do you get for expected value then, Andy? Yeah, about 2.05. So on long-term average, you're going to get about a little over 2 pieces of junk mail per day. That's a lot less than what I get in my mailbox, I'll tell you that much right now.
Yeah, like college. Like, John, we really want you to go to college. Like, don't mind.
All right, here's your assignment.